Hello, in this video, I want to show you how to compute expected counts and chi-square statistic for any specific cell in the total chi-square statistic using an online website that's different from StatKey. So this is from the Lock 5 textbook, section 7.2. We're looking at a test for association between two categorical variables. And I want to look at homework question number 31 from that section. And here we're given two categorical variables. One variable is what group you belong in, so group 1, 2, or 3. And the second categorical variable is whether you say yes or no to some specific question. So we would be testing using chi-square to test does whether someone say yes or no have some association between what group they belong to. But for this video, I just want to go through kind of more the computation. So how do we compute expected counts and contribution to the chi-square statistic for that cell? And again, I'm going to use a chi-square test online calculator. So the textbook kind of goes through how to compute this by hand. It's not too terribly difficult, but it is a little bit tedious to compute your expected counts and chi-squared contributions for each of these 6 cells. So if you do want to know how to do that, read through the textbook, or you could Google how to compute expected counts, chi-squared test for association, or test for independence is the other way that this test is described. But here I gave you a link on the class website on Canvas for a chi-squared test of association calculator. So if you open up that link, it should look like this. And what I want to do is I want to match this up. I want to match up the number of rows and columns with our given data. So all that data is these 6 cells right here, 6 cells in the middle. Everything else is just either total or a label. So I need to make sure I have 3 rows because I had 3 groups. And then I had a yes and a no answer. So I just have 6 cells of actually computing expected counts and chi-squared test contribution. So I'm going to type in 5644 into the first row. 56 and 44. Second row 132 and then 68. And then the last row 72, 28. And I want to see the expected counts and the chi-squared. And right here, notice in each cell, group 1 that said yes, we have 56. This top entry is your observed count. You type in your observed counts. The number below is the expected count. And that comes from assuming whether you say yes or no has no dependency or association with group you're in. It should have been 65. And then the very bottom entry in this cell is the chi-squared contribution, so 1.246. So the farther apart the expected count is from the observed, the larger the chi-squared contribution. So group 2 has 132, 130. Since these are really close, they're only off by 2, the chi-squared contribution is only 0.0308. And again, these formulas are derived and shown how to use in the section in the textbook. And the total chi-squared distribution, or contributions, shown at the bottom of the website right here. And all this is adding up the chi-squared contribution for each of these cells. So add up these 6 numbers, 1.2462, 2.3143, 0.0308, 0.0571, 0.75, 1.4. Add up those 6 numbers to get a 5.8022, and we get a p-value. So you could take this chi-squared and go to StatKey into the chi-squared distribution, get the p-value, but it should be the same or fairly close. There could be some rounding issues. Most of the answers in our textbook round to just 3 decimals at each step, so the numbers might be slightly off, but it should be fairly close. So if we're looking at, for this one, we're looking at the expected count and the contribution of chi-squared For group 3 and yes, that's this third row, first column, the 72. So right here, the expected count is 65, and the chi-squared should be about 0.7538. Excuse me. And if I clicked on the answer, it gives us the same value. And if you do want to do these by hand, again, it's not difficult. I'd say it's just more tedious to compute. If you have group 3 row total, yes column total divided by the total of everyone to get the 65. And the chi-square distribution, similar to those residuals or standard deviation, it's the difference between the two squared and then divided by the expected count to get your chi-squared contribution.